Welcome all to this topic, and we are actually looking at a course in mechanical science offered to students who are undertaking the certificate in mechanical engineering program. So in this presentation, we're going to look at the topic friction force, which is one of the topics in these course units. So under this topic, we are going to discuss some learning outcomes, and by the end of this topic, you're expected to cover these learning outcomes. The first one is define friction force. You should also be able to explain the types of friction force that exist. Another learning outcome, number 3, is to state the laws of dry friction, and finally be able to explain the advantages and disadvantages of friction force. So to begin with, I want us to define the term friction force, and it is usually seen as a force, as the term says. So it is a force which prevents the motion or the movement of a body, and it is usually in the direction opposite to that of motion of a given body. So if a body is moving to the right, then from the definition of the force or the friction force, it is supposed to act against. In this case, it will be moving to the left in an attempt to derail the movement of the said body. So it is simply seen as a force of resistance, which actually tends to prevent or retard the motion of the body. So given on this screen, we have an example of a body which is resting on a horizontal surface, and the surface is actually rough. Because for friction to be present, then we deal with rough surfaces which are able to produce the friction force. So on the said diagram, we have a body that is resting on a horizontal surface, and there are forces that are acting on this body are indicated. So one of the forces is the applied force, which is supposed to produce the motion. So the applied force is acting towards the right, and it will attempt to make the body move in a forward manner. Then the friction force, on the other hand, which is a force that is opposing the motion, it will be acting in the opposite direction of the motion of the body. In this case, it is acting towards the left, appearing to resist the motion of this body. Then another force that is present on this body, as indicated, is the normal force that is acting towards the upward direction. So the normal force actually comes from Newton's third law of motion that says that for every action force, there is always an equal and opposite reaction force. In this case, the action force is the weight of this body or the block itself. So the weight is acting or is exerting a force on the horizontal surface as the action force in a downward manner. Then the reaction force to that weight is the normal force, which is drawn with the red arrow pointing upwards. So these forces are all acting on the said body. And you are going to see how the normal force contributes to this friction force or the magnitude of the friction force. Because when we are deriving the expression for the friction force, we are going to see it is a function of the normal force. And the higher the normal force, the higher the friction force for a body that is lying on a horizontal surface. Then the types of friction force can actually be divided into two, or is classified into two. One of them being dynamic friction, and the other category being static friction. We refer to them as types of friction force. So the difference between the two depends on the state of the body on which the friction, or the body which is experiencing the friction force. So in simple terms, the word dynamic simply shows a body that is in motion or is in the process of moving, whereas static, on the other hand, is simply the opposite of dynamic, associated with bodies at rest. So when a body is moving, or to start with, if this body, which is shown on the previous slide, if the body is not moving, that means the applied force is not able to overcome the friction force. If that is the case, then the body will remain stationary or in a static manner. The body will only start to move if at all the applied force is able to overcome the friction force. So in the case whereby the applied force is not able to overcome the friction force, then we have what we are referring to as static friction. Simple friction experienced by bodies which are in motion, or which are at rest, that is. Sorry. So static friction is friction experienced by bodies which are at rest. On the other hand, dynamic friction, it is the friction experienced by bodies which are in motion. So when the body starts to move, and that will only happen if the applied force is able to overcome the force of friction, then the body will be able to move, and although it is moving, it will still be experiencing the friction which is dynamic in nature. So this one is associated with bodies which are in motion. And if you are to compare the two magnitudes of these two forces, or the two forces of friction, you find that when a body is at rest, it experiences more friction force as opposed to dynamic friction. Then factors affecting the magnitude of friction, we refer to this as factors, and they are also referred to as laws of dry friction. From the learning outcome, we expected to state the laws of dry friction. Dry friction meaning it is a friction experienced by bodies on a surface which is not lubricated. If there is no lubrication, then we talk about dry friction. And that dry friction, its magnitude depends on these factors. And they are simply the laws of dry friction. So number one is that the size of the friction force depends on the type of surface. Now in this case, we are going to discuss the types of surfaces as two, whereby you have either a smooth surface or a rough surface in terms of the type of the surface. So for the case of a rough surface, then the friction force is more as opposed to when the surface is smooth. Factor number two is that the size of friction force depends on the size of the normal force. They are simply directly related or proportional to one another. The higher the normal force, the higher the friction force. Then finally we have the direction of the friction force being always opposite to that of motion, as we had indicated in the earlier diagram. So under dynamic friction, you can categorize it into two types. One of them being sliding friction and the other one rolling friction force. So the next diagram indicates an example of a sliding friction, whereby you're given a piston and a cylinder, and the piston rod is moving inside the cylinder. You can actually visualize this as a double acting cylinder in which the cylinder moves, or the rod moves in two directions depending on the direction of the fluid coming into the cylinder. So this sliding friction, as the rod is sliding over the cylinder. The other type is rolling friction, associated with bodies which are in contact with each other. A good example being a wheel that is running on a railway track. So if the wheel is running forward in a clockwise manner, then the friction resistance will be acting in the opposite sense. So to be able to calculate the magnitude of friction force, there is a coefficient of friction force which is obtained by dividing the friction force itself by the normal force. So this coefficient comes in because of the direct relationship between the force and the normal force. So the friction force, from the laws of dry friction, we saw it is directly proportional to the normal force. And when you get rid of the proportionality sign, you introduce a constant of proportionality, which is this coefficient of friction force, into the equation, and you can be able to make it the subject and be able to come up with this expression for the coefficient of friction force. So it is simply a measure of the amount of friction that exists between two surfaces. When the value is high, then it indicates a high value for the friction force, and when it is low, then it is simply the opposite. The force of friction will be less. So this is the same diagram, but now including the value for the friction force as a product of the coefficient of friction force and the normal force, giving us the value for the friction force. So different surfaces will have different values of this coefficient as indicated there. So for a polished oil metal surface, its value is less than 0.1, meaning the friction force associated with such surfaces will be less as compared to that of rubber on tarmac, which has a very high value of 1.0, indicating a very high force of friction between the two surfaces, that is the rubber and the tarmac road. Applications of friction force. So different applications find friction force either desirable or not desirable. So there are cases whereby friction will be of advantage and others it will be of disadvantage. So a case example where friction is advantageous is when power is being transmitted from one shaft to another by the use of belts or even chains. So this is a shaft that is rotating and you want to transmit that power to another shaft by simply coupling the two with a belt drive. So friction finds application here in the sense that the power will only be transmitted, or maximum power will be transmitted from one shaft to the other when the value of friction force between the belt and the shafts or the flywheels is actually high. So the belt is supposed to capture the flywheels with a higher value of friction for power to be transmitted effectively. Other examples that indicate friction are fastening devices which rely on friction force. For example, when you want to tighten screws, it depends on friction force. Application of brakes and clutches in automotives simply relies heavily on the friction force being present, otherwise they will not be able to work. Then also the absence of friction forces will not be, acceleration along surfaces will not be possible. For example, for a vehicle to move forward, then it requires friction to be present for the forward motion to occur, otherwise slipping will actually take place, which is not desirable. On the other hand, disadvantages of friction include waste of energy, which is associated with bearings, and also the heat generated is also another disadvantage. Then the friction force also causes wear and tear, for example in the shoe linings or the brake shoe linings in vehicles. So with time, the brake linings have to be replaced because of the effect of friction wearing them out. And also another instant where energy is wasted is when you are moving in the direction opposite that of the wind. So you tend to use much more energy as compared to when the wind is blowing in the same direction as the body is moving. So from these slides, we have been able to see or cover the learning outcomes that had been stated earlier. That is, define friction force, state the types of friction force that we have, laws of dry friction, and also saw the applications of friction in terms of the advantageous part of it and also the disadvantages associated with this friction force. So I hope you have enjoyed your lesson and look forward to meeting you in the next class, and hopefully you'll be able to go through these notes on your own and read further on the same. So again, thank you very much and enjoy your next lesson. Thank you.